Hello, in this video I am going to make Connect 4 using Windows Forms instead of WPF because WinForms makes drawing a little bit easier, a lot easier. So we'll do that. And this is going to be a two-dimensional array activity where we learn how to work with grid structures. So I'm going to create a new project. And if you have not actually seen Connect 4, why should I assume that you know what it is? It is there you go, right? You try to make patterns of 4 in a row, you drop the checkers into the vertical board, and you try to make, and you win by getting a pattern that's horizontal, diagonal, or vertical. So that's what we're going to make. So I'm going to make a new WinForms project here called Connect 4, and save that, and then I'm going to go import the resources for it. So to import the resources, that's like we've done many times, project, properties, resources, add existing file. And now I'm going to go grab the resources for that, and for you they'll either be in a zip file or on a network drive. So let me go find mine. They will be in week 6 folder. I'm going to grab all of this stuff, and you'll see why we need the blank board in a minute. Let's just grab all of that stuff, and I used Control A to select all of them, and now we've got them all in our projects, and we don't have to build a resource dictionary and set the build action and all that. It'll just magically work. Alright, so let's go to our form here and set this up. I am going to change the text property on that form to be Connect 4. And I'm going to add some controls to it. So I'm going to go to the View menu and pull up the toolbox. And I'm going to add a menu strip. So I'm going to type in menu and it'll filter the one I want. And I'll just put the menu strip up there. And I'm not even going to bother putting these things in here yet. They're just placeholders. The ampersand is for making something a keyboard shortcut. And now what I'm going to do is put in a picture box, and this is going to be the playing area. Our playing area is going to be 350 by 50. So I'm going to find the size property of that picture box down here, and I'm going to set it to 350 by 300 because that'll give us a 7 by 6 grid of checkers. There we go. And I can kind of resize this a little bit. So picture box 1 is going to be the board, and then let's add another picture box to display whose turn it is. So let's pull up our toolbox again and find the picture box control, and let's drag that on here. And let's go select an image for that. So if I click on the little black arrow here, I can choose an image to put in that box. And let's just say black goes first. So I'll select turn black. There we go. And I can make this thing, the size mode, I'll say auto size, so it'll fit nicely around the image. Maybe I'll just put a label on top of that too. So let me pull up my toolbox again, and I'm going to type in a label. And I'll drag that on top of my image. And I will set the text property of the label to be turn. So now we know whose turn it is. Is that the right image? Let's find out. What else do we have? Choose image. Yep, I guess that's the right one. Now, and let me shrink this just a little bit, just to make it a little more, kind of compact. So for this picture box right here, I'm going to go select the image of the board, because what I'm going to do, or the way we're going to drop checkers, is by putting in buttons on top of our board. So we'll click the button and it'll drop a checker in that column. So we need to kind of see what the board's going to look like in order to line up the buttons. So I'm going to select blank board and put it in there. There it is, fits nicely. Okay. And now what I'm going to do is put some buttons on top of that. So let's pull up the toolbox, and I'm going to put in a button. And you can see it's a little bit wide, so let's just kind of collapse that. So that's about 45 pixels wide, seems to work. And let's change the text to, can we change the text to just a space or blank or something? Would that work? I guess. We could put numbers in there. I don't know, really doesn't matter. Let's, and then what I'm gonna do is copy that. I mean, or we could put letters in there too and have the, we could be able to drop checkers using using the keyboard. Maybe we'll do that and figure it out later. All right, so now what I'm just going to do is copy and paste these buttons. So I've got one over every column. Paste. Okay. So now we've got our buttons, and while we're here, now that we've got our buttons, we don't need this background anymore. So let's go, or let's get rid of that. So let's say choose image, none. We're going to clean out our background. We're going to take care of drawing this by hand, which means we need to put a paint event on this control. It's very important we have the picture box control selected, not the form. This is the thing we're going to be in charge of drawing here. So let me go to my lightning bolt, which allows me to hook up to event notifications, and I'm going to scroll down until I can find paint. And I'm going to double click in the blank area next to paint. And that will make me the function that is responsible for painting that control. Or this function will be responsible for repainting that control when it receives a paint message. All right, so what else do we need? Let's also, since we're in here, add let's click on all our buttons here and just create the event handlers for them. No, maybe. All right, let's not do that yet. Let's go get our let's go add the variables to our project here, and then we can then we'll work on something later. So my thought was that rather than numbering these things with letters, if we put numbers like in here, what we could do is we could wire all of these buttons up to the same event handler, and that would save us a lot of code. So we'll investigate that property or that possibility in a second. That'll be more sophisticated than having a different function for every button. So let's go look at the code here and that we've got so far. And let's go add some variables that we know we're going to need. So let's define some constants so that the two players are red and black, and but a square could be empty as well. So we're going to want to make constants for red, black, and empty. We're going to have to declare our board, which is going to be a two-dimensional array of integers, which stores those codes, and we're going to need a code to keep track of whose turn it is. So let's make some constants. Let's define empty to be 0, because that'll make our life a little bit easier. And then let's define red and black to be 1 and 2. And then what do we need? I got excited there. Then let's make a variable to declare, to store whose turn it is. So let's make a variable called turn, and we'll set it equal to black. and then let's make our board. That's going to, oh, and let's define the width and height of our board. Those will be constants. So our board is going to be 6 tall, 6 squares tall, and it's going to be 7 squares, or 7 checkers wide. There we go. So that's the size of our board. Now let's go actually to create our board. So I'm going to make a 2-dimensional array of integers. So it's the data type followed by the square brackets with a comma in the middle to indicate that is a 2-dimensional array. I'll call it board. Now arrays are reference types, so I need to allocate them. So I'll use the new operator to do that, just like in C++ or Java, and I will allocate a width, height, size grid of integers. So that gives me a 7 by 6 grid of integers. All right, now let's go add a function to draw our board. So there's our paint function. Let's go draw our board. Now you may be saying, do we have to initialize our board? Do we have to reset our board? We can add a function like that later. What we're going for here, though, is by making the board will default to being zeros, and 0 will be empty. So our board will be filled with empties. It'll be initialized correctly. Although if we want to reset the game, we will need to make a function to set everything in the 2D array back to empty, or back to 0. So when we need to examine every row and every column, every possibility of row and column. So the mechanism for doing that is a nested loop, a loop inside of a for loop. So let's use a for loop that goes across all of our columns, and then within there we go down each row. So let's have another for loop, and we use j as our loop variable. And to do that, I just hit FOR and type tab twice, and Visual Studio auto-completed it for you. There is height. Okay, so now we're going to examine every possibility of row and column. For the variables I and j. And now what we want to do is look at the value in the board at ij. And if it's empty, we'll draw the empty square. If it's red, we'll draw the red square. If it's black, we'll draw the black square. I like using lookup tables for images. We could also, there's only 3 cases here, so we could just use an if statement. It's not going to kill us. Oh, and how big are our images? I think they're 50 by 50. We'll figure that out here in a second, because we're going to have to scale up from array coordinates, which are in units of 1, to screen coordinates, which are in units of, I think they're 50. I mean, we could do that by looking at one of our squares and seeing, do we have any, if I open this thing up in Blend, does it give me any info on it? I don't really, no, I don't see any sort of, all right, yeah, it's 50 by 50. All right, so let's kill that thing. So let's make another constant called, tile size or something. And we will set it to 50. All right. So back down here into our loop, as we're scanning across every combination of row and column, we want to look at what's on the board. If it's empty, we draw the empty tile. If it's red, we draw the red tile. If it's black, we draw the black tile. Let's use an if statement for that. So I just hit if, typed if, tab, tab. Visual Studio stubs it out for me. Board at ij, right? So I have one set of square brackets, and I specify the indexes between the commas, right? It's not C++, not Java. We've got one set of square brackets. Let's say if it's equal to empty, well then what do we want to do? Well, let me just streamline this a little bit. I'm going to make an image called tile, and I'm going to set it equal to properties.resources. I'm going to set it to the empty tile. Square empty. and then I'll say if the board is red, set tile to the red square. Otherwise, if it's black, set it to the black square. So that's properties, resources, square, black. And now I have stored in this variable called tile, I have the tile, I have the image for the tile to draw. I've found the image that corresponds to the value in my two-dimensional array. And then I just need to draw it. So for that, we have a paint event args here. This contains the graphics object to draw on. So I will draw on the graphics object that is coming in with this parameter. So let's just see what's in there, and there's our graphics object. That's our canvas, and it has a function in it called draw image. And in the draw image function, there are 30 overloads. We can specify the image to draw and where to draw it. So we want to draw our tile at I and j. Now, I and j are in units of 1 because arrays are inherently in units of 1. I need to scale this up to screen coordinates. So I'm going to multiply I and j times the tile size. And that will bring my array coordinates up to screen coordinates. And, well, let's just run it and see if it works. So cover every combination of row and column, look at the image in that cell, and use that to pick the appropriate tile, and then draw that tile. So let's run it, and we should see an empty board. There we go. So there's our board. It's all empty. All right. So, all right, what are we going to do now? Let me think about this. Do we want to wire all of these up to one event handler? Do we want to be slick, or do we want to just kind of be brute force stupid and have 8 functions? Let me think about it. So let's pop over to PowerPoint for a second here and think about what we're going to do in our function to drop a checker. We're going to start at the bottom of the board and crawl up a column. And we're going to scan for the first empty square. And when we do that, we'll set that to the turn color and then break. That will be easier than trying to actually model a checker coming down, because what we'd have to do is we'd have to peek ahead and then possibly back up. It's a little bit easier to just start at the bottom and work your way up. And if you can't put a checker there, then don't change the turn, and it doesn't break the game. So when one of these buttons is clicked, we'll know what column to drop the checker in based on the button, and then we'll use a while loop to start at height -1 and work our way up to 0, trying to find an open slot to put a checker in. So that's what we're going to do. We're going to say, okay, is that slot free? No, keep going. Is that slot free? Keep going. No. Is that slot free? Keep going. No, no, no. Aha, yes. Put the red checker there, flip the turn, and break, and then we're done. And also we'll have to redraw the board too. So that's what we're doing. I'm going to go back to Visual Studio here, and let's make a function called drop checker that takes the column to put a checker in. Let's call it, let's make it a void function. We'll call it drop checker, and it'll take the column to put the checker in. So now let's do our while loop. We're going to start at, let's make a variable called I. That'll be our loop counter, and we'll set it to height -1 because the indexes start at 0. And if we don't take care of the -1, then we're going to start our search off the bottom of the array. And then let's do a while loop. We could use a for loop too and count down. While I is greater than or equal to 0, and we want greater than or equal to 0 because 0 is a valid index to check. And then let's do I minus here. So count down, which means go up the columns trying to find an empty square. And then we'll say if the board at that column and at row I is equal to empty, then let's put the turn color there. So we'll say board equals the turn and then break. So that'll jump us out of oh, you know, we probably want to flip the turn, and we want to play a sound. And do we ever add our sound effect? I don't know. The sound effects are really kind of essential for this to be fun to play. Let's go add our sound effect. Let's go up to the top here, and let's add using system.media so we can play sounds. And then let's add a sound player. I'll call it, you know, I don't know, I'll just call it SND equals new sound player. And I have to go find that thing in my resource tree. Use properties.resources. Sound checker drop. There it is. Okay, so there is my checker sound. And all right, so let's I'm going to flip this. Let's play our sound, SND dot play, and then let's flip the turn. So we can say if the turn equals red, turn is now black, otherwise turn equals red. So that'll flip the turn. And then how do we trigger a repaint? We have to tell the board that it was invalidated. Redraw. So let's tell picture box 1 it is invalidated. Invalidate. So that'll trigger a repaint. And we also need to this needs to be just a little bit more complicated. We need to change the image that's on the in the turn box. So let's go do that. Let's put a so that's picture box 2, and let's change its image property to be properties.resources. Whatever, it's the black turn. I think it's just called turn black. There we go. Otherwise, I goofed that up, sorry. Okay. And later, you know, we might move this down into a function if we need it in more than one place. It would not make sense to duplicate that code. So let's see what we've got here. So crawl up the board looking for an open space. If we find one, put the turn color there, play the checker sound, flip the turn, and trigger a repaint, and then break. That means stop looping. Jump out of one level of looping. All right, so we've got this drop checker function. Now, the problem is it's not actually wired up to any buttons. So let's go change that. So let's, just to be a little on the slick side here, let's make an event handler. And we'll use the same event handler for all of these guys. So I'm going to go back to my code. I'll call it like drop checker event. And it'll be an event handler, so it'll take the control. Let's call the control a button because we know it's going to be a button. And it'll take an event arg structure, and we'll call that E. And in here, we will figure out how to call this function with the appropriate row. So let's go back to our form designer here, and if I select all of these buttons and go to the lightning bolt, I should be able to go down to the click function here, and I should actually be able to select oh, it's not going to work. Hang on. Let's go back to the form, And I'm going to change this from being a button to being an object. And maybe I need to rebuild my solution here. So Visual Studio should be able to find this function because of the signature. So if I go to my form designer, what happens? If I go to my click function here, now you see drop checker event is there. So I had to rebuild my project. And all right, so now it shows up because of that event signature. All right, now the question is, if they're all wired up to the same event handler, how does the event handler know what column to put the buttons in? Well, we've got a label, right? Or the buttons have names too. This is 1, 2, 3, 4, 5, 6, 7. We could get the last character off the name. I think what we should do is take the character code out of the button name and turn that. If we subtract 65 from it, we'll turn the ASCII value into a number of the column. So this will be like A is a 65. If we subtract 65, we'll get 0, which is the column we want to drop the checker in. That would be kind of slick. So in order to do that, though, I need to cast B to a button. So I will do that in the C# way. Call it btn equals B as button. And then let me get the column name. Let me see if I can do this. Let me think about this. All right, well, I think we can do this. Let's make a character called CH, and we will set it to, we'll get the character out of the button's name. So the button's name is a text string, and we just want the character. We don't want the string. We need the first letter. So that's a character versus a string. So let me assign that character to the button's name property, and I can say square brackets 0 because strings are arrays of characters, and I can index them using the square brackets operator. And then let me see what happens here if I do int, I'll call it char code. I'll say let's just see what we get here. Int ASCII code equals int ch. Let's just cast that character to an integer and see what happens. I'm going to put a breakpoint here, and let's just run it and watch. This is going to be interesting. So let me click on a button, and the button's name is well, there's our button. Our button's name is button 1. Oh, okay, so we need the button's text property. We don't want the button's name. There was my mistake. Kind of thought I was going off the rail there. All right, let's try that again. So now let's get the name property from the button. So there's the letter A. So A is a, how do we get a 32, a space, out of the text? Well, if you highlight over this, you'll see that the name of the button is actually space A. So I made a mistake there. I will go fix my button name, and I swear this will work. I know this is kind of a long way to go for this activity, but I just wanted to do something a little bit interesting. For those of you who kind of understand, who like to know how things work under the hood or want to see some cool tricks. So our button's name is A, and you can see the CH is a 65. That is the character code for an A. So now if I cast that to an integer, you can see the ASCII code is a 65. So if I subtract 65 off the ASCII code, I'll get the column number. So let me subtract 65 off of this. I don't really know if I need the parens. I don't think I do. But that should be our column number. And then let's call drop checker, and we'll drop it in column. Well, our ASCII code is really the column. Now I don't like it being called ASCII code. It should just be called column. All right, stream of consciousness coding is dangerous. There we go. All right. We're going to harness the power of ASCII codes to save us some work. The column is 0, so let's drop a checker in column 0, and it'll work. It did. Well, it works. Yay. Let's try to fill up a column and see what happens. See, it doesn't break. So that's pretty slick. All right, so now that we got that working, I think I will call this video done, and then what we'll do is in the next video is we will put in some extra logic here to do the win checking, and then we will turn this thing into a game we can play against the computer using some AI. So there we go. Connect 4. Using a 2D array, and what else did we do? We kind of demonstrated we could wire up multiple controls to the same event handler, and then we're actually being slick and using the name of the control, or the text property of the control. We're getting that, converting it to an ASCII code, and subtracting 65 to get the column number, and then we go to that column number, and we go to the bottom, and we crawl up looking for an empty square, and then we find one, we put the checker there and flip the turn, and trigger a repaint. So actually not a very complicated game, except for all that ridiculousness with the ASCII codes. And all right, so next video we start doing some win checking.